Hello and welcome to my update on our Leaf SDL project. Let me just put this window in the front here. I just want to give these brief updates because what I've started on is a project to get Leaf doing something useful, and I've decided to integrate that with the SDL library so that we can show graphics on the screen. Hey Sinclair, and we'll see who was around this morning, who actually likes to watch the show in the morning, and this is going to go into the technical details quite a bit about the compiler, a little bit about the language, not so much about SDL. And to answer Ergengrand's question, this evening, I'll get on this evening again. So this evening we'll get back to the Rust bots for Botters of the Galaxy, and we'll see how that's doing. And until then, I'm going to be working on a bit of Leaf this morning. This update's only going to be about half an hour, so I just want to show where I am. And the graphic of the show, just to quickly show where I am. Yeah, thanks for that. We'll get to Legendary too after. So on Leaf, this is where we are. We have this demo program, and it shows a leaf on the screen. Very briefly shows a leaf on the screen, and I'll show you why in a second. So I've been working on this a little bit for 2 weeks, and this is using the SDL library. And this is the very ugly Leaf code at the moment because interfaces to external libraries are going to be complicated. All the stuff at the top is how we import a C function, so C library function. So for example, the create window, we import, this is the actual library name, and this is our name, and this is the format of it. And you have a lot of stuff like raw-array, ABI character, ABI's interface, ABI int, ABI int. These are not the Leaf types, these are the native types, and then some flags, and then it gives back a window, a value pointer to it, which right now we just left as empty because we don't need to look at it. And then we mark it raw no throw because it's a system library and we don't want to do anything with it, or it doesn't produce any errors. It doesn't produce any errors, and it's not a special function type. SDL surface has some data in it. We get the window surface. So this is the very basic importing stuff. This was already done beforehand. This Leaf already supported this before. Like this value pointer stuff, there was a little weak point in this that I had to add, but otherwise it worked. We were able to grab the surface and look at the data of it. And so the main program we have here, and again, this isn't very indicative of what we're going to see in Leaf because this is really all low-level interfaces. Once we get a few more steps into the show, we'll do it some more. And this is the main function. Let me improve the font size here in case you want to see this. Okay, and all I do is I call run, otherwise I print the current failure. And there's actually an underscore there. There we go, just got to get the right font size. Kate's having a lot of problems lately. I think I'm going to have to abandon it because there's too many defects. And so this prints the current failure. And so for example, if we had an error, let me just quickly change the name of the file to get an error on it. So you get an error, couldn't open. This is actually coming from SDL. Our error is here, error SDL fail. And this part of what I did is I have this, the failure is actually in this check SDL. So every call to SDL, it's a classic C library. So right here we call SDL init, SDL init video, and check SDL, SDL init queue. And that's the code. So our check SDL function here just says if the code's 0, then we're fine. Otherwise, print where we failed. And that's just taking the name we passed it. So SDL init down here. And then we print SDL error. SDL error, this one looks a bit messy, and I'm going to clean this up somehow because Leaf doesn't print C strings yet. There's no facility. Okay, there's very little standard library at all. Just keep in mind that I have virtually no standard library. And so the SDL errors, we call SDL error, and this function's right here. It's called import SDL error. This is actually the one you can look it up online. I think I actually have it there. We're going to take a look at it and see how this works. This is an easy one. Get error. And it's a standard function. It returns a constant character pointer. We don't have constant set in Leaf, but that's not a big issue. So what we do is we say multi-SDL error. This should be func, small error, I haven't fixed yet. And it takes no arguments, and it returns a raw array of ABI character. Now a raw array is because the native Leaf arrays have a length included in them. A raw array does not. ABI character because we don't know what character type the ABI has. If we're trying to be cross-platform, I'm just saying whatever the ABI would define character as here now, so this would be like a C character in most systems, so an 8-bit or a 7-bit sign value. I think I do 8-bit octets. And so this gives us error. And this is why we can't print it directly, because Leaf doesn't see this as something printable. It's a raw array of some random binary type. It doesn't see it as printable yet. There's no print function for it. So I manually loop over it like you would very low level. I take the loop, and while we don't have, and these are null terminated, and native APIs are null terminated, so we simply loop over it. While we don't encounter a null, we print out the character by character, and this character val says convert this value into an actual Leaf character. And I'm just assuming this is ASCII here. If they have high order values in here, or actually if this is a UTF-8 string, this will actually break because I'm encoding it bit by bit. And so what I really need here is a print ABI string function that will actually take care and say, look, I assume the ABI is printing an UTF-8 string, let's print that instead. But that's a minor detail. But I really needed this function here to print the error out, because when it got down to this load function here, this load function, SDL from file, which was loading, okay, this isn't actually load function, it was failing, but this is the one that loads a bitmap. It creates a file handle, and then down here in load bitmap, I give that and I load this file. And this was actually failing originally. So in the original version when I did this, I couldn't get a bitmap on the screen. I just had a green window, and it would fail. They would say it failed. It would fail. And so I had to do a lot of work in Leaf to figure out, well, why is it failing? So the first thing I had to do is that I had to check this SDL pointer, and this was an issue, is that even though we have this value pointer, there was absolutely no way in Leaf to inspect it to get for a null. I had no nullables because Leaf itself doesn't use nulls that way, but obviously if you're dealing with an API you need to. So I introduced this function called asABI-pointer. Now this comes up higher in the file. We have an ABI pointer. We must have a few of these here. ABI pointer. And they're right here, inside this SDL service ABI pointer, ABI pointer. These are what are called untyped pointers. This is equivalent to like a void star in C or C++. These are pointers to something it just doesn't know about. And actually in Leaf, this ABI pointer is just a binary value. It just takes, in this case, it's going to be a 64-bit binary value. It just opaque. It doesn't know what it is. But you can work with it as an integer. And that's the important thing. ABI pointers kind of work, well, not like an integer, like a binary. You can do basic math. And that's why I needed to compare to 0. Because if you look at this the value pointer function here, value pointer is not an integral type. You cannot work with this. You cannot work this value at all. It's completely opaque. You cannot access to it. And that's what this function here, asABI-pointer, does, is it takes a value pointer and gives you the raw native pointer value for it, assuming there is one. If there isn't one, it's going to fail on you, or if it's not the right point, it's going to fail on you, tell you that. This case, it's not going to fail here because we know for sure we have it right here. And so I had to check this pointer, and this was failing. This function was failing, and it was really weird. Actually, at first it was this function failing because this didn't have to use the pointer comparison. I saw this function fail first, and that drove me to create this one so I could see why this function's failing. And that was printing an error, and that's up in check SDL pointer. I check if it's 0. If it's not 0, it's okay. Otherwise, we print where it failed, and we print SDL error again. And this is where I could actually see, and I wonder if I still have it back on my scroll back here. Probably not. This error right here, file is not a Windows BMP file. Now this was really kind of concerning at first. It's like, okay, what have I done wrong here? It was a BMP file. I saved it in a GIMP as a BMP file, and it just didn't load it. And so it's like, it's not a BMP file. Oops, it's pretty small. And so that was kind of bugging me. I was like, uh-oh. But that was all the work getting there. So I was so happy to get there because that was quite a bit of work in Leaf. This asABI-pointer function required a bit of work in the typing system to convince the thing that you could actually do this. I mean, it was more about passing the type thing around. I had to pass type manager a bit around. And this is implemented. I wonder if I have it here. There's a built-in, and this is what the code for the compiler actually looks like, asABI-pointer. So I added it to the built-in map. This is now a built-in function. It probably won't keep this name in the end, but I just used one quickly, and I don't mind changing names later. And asABI-pointer. So this is what some compiler code looks like for this. And I should just remove these debug statements. They were here because something was going wrong here. And so the compiler code in this case, just to go through how compilers work a bit, I check the built-in if it has one argument. If it doesn't have one argument, then there's something wrong. And because it's a built-in, it handles arguments very differently than non-built-in functions. And then I convert the expression, and here I check if it's a value pointer. You can see it is value pointer, otherwise it gives you an error. And otherwise we transform this, so as ABI pointer disappears, the code no longer has it, and it writes it into this transform function instead. And this transform function is a special expression, and we have a few of these because some of them you can't represent in a high-level language. I have a few of these transforms to pass right down to the IR generator, and this tells the IR generator something like, there's something with this here. And so the IR generator is going to look and say, I know how to deal with this. And in this case, it's very simple. Because it's really just a C-level cast, the IR generator just looks at this and goes, oh, okay, I have a pointer. I just have to change the logical type. And this is because LLVM is typed. You need to keep the type. So that's literally all that function does, is change the type of the thing using a cast instruction. And so that lets me load it, and that lets show it's not a bitmap. I have no idea what it meant that it wasn't a bitmap. So I went back to GIMP, I saved it, I looked at the options, I didn't change the options, and I pressed saved again, and it worked. So I really don't know why it wasn't accepting bitmap, and that loads it. And we call blitz surface here, and we don't pass any rectangles. That'll be the next thing to do, is pass a rectangle in here to get it draw multiple places. And I had to do a little bit of work there, because now the second thing here is that a lot of these APIs take this problem, they take a pointer or they take null, and Leaf can't quite deal with that yet. Leaf has an object, and it doesn't like nulls. You can't have a null value pointer. It has to be an actual value. So I'm going to have to create some sort of thing here that can convert between a pointer and a null, and says, look, I'm going to get maybe an optional. So it'll probably be an optional type, and if you pass it to one of these ABI null pointers, it's going to pass null if it's an optional unset, and it's going to pass the pointer otherwise. And I'll see if I can get that working. And so I load that, and so this why it's so brief up there's this SDL delay down here, so I'll show that. So now we have this image showing, and that's all the blitz surface does, and that's basically what the update is, and that's as far as I've got. Now as to point, why do I have this delay in here? Because we don't have any event processing yet. Without the delay, you don't see anything. It's not even long enough to see a flicker on the screen. Sometimes it is. You can see it load, but it's not even long enough to show the flicker. If we SDL delay back to 1, and this was doing this for debugging, you don't have to compile it again. Incidentally, that is compiling and running the executable time. It's a fast turnaround, so when you make a file, this command here, it builds the executable, and it runs it. This is just bash. So that's fairly quick, and it's a nice turnaround time then. And then we just do the cleanup in the end. Free service, destroy window, and quit. It's not the most exciting update. I'm going to write a little article about it as well to show some of these things, but I just thought I'd do this to show where we are right now, sort of as the basis point. Like, look, I've got a window right now. It's not the most exciting window, but here you have it. You have a window. It's got a graphic in it. It's got the Leaf logo in it. And that represents actually quite a bit of progress so far. I mean, in terms of using language, we've done actual algorithms before. We've done working algorithms. And the purpose of doing this is I actually want to visualize the algorithms. And I think that'll go a lot better towards that if we can actually visualize them. And I'm going to use SDL that ends. And the reason I chose SDL is mainly because it has that windowing stuff. I didn't want to jump right to GL because that would mean I'd have to actually talk to a windowing system as well. But the SDL basically says, look, here's just create the window, just go for it. And so it's the easiest way I can actually do this, or the quickest way. And the functions are very straight interface. Some things I have to watch out for was this SDL load bitmap, for example, wherever it is, SDL load bitmap. I was using this originally, but this isn't a function in SDL. This function doesn't exist, and so I was getting really confused. Why does this function not exist? And it's because this is actually just a define in the file. So I think that's actually over there. I can show you that there. If it's even there. I thought I had it running here. Let's get this one away. I thought I had it in there. Let's see it again. I was looking in there, wherever I was looking. Let me check. I think I know where it was. Sorry about that. So this is defined in the file, and this is in the, I guess it's in user include SDL. And this is one of those things we have to watch when importing foreign libraries, is that you don't always have, I think this is probably an SDL, I don't remember anymore. Just an SDL. Now we can search for it. SDL upper blit. And it was in the same file upper blit was, where we can say SDL load. There it is, load. Right there. So the surface, so SDL load bitmap is actually just a define. And this will be interesting when we actually go to the point of doing a code to foreign function interface, that we have things that can actually load this. There is a library that can load this file. Right now I've hand-coded all of this stuff. I've hand-coded all of this, but this is obviously, if you want to do a full library, it's going to be painfully inefficient. So there are libraries that convert, like from header files, they read them in, and then they output a standard format, and then I can import them as Leaf. But things like load bitmap, I don't know how it's going to work, because this is not a function. It's just a macro. And there are several of them in SDL, a few macros. And so I just have to look for the header file, and then I have to write these little bits of functions, and I just write them on its own. And that way we have the file, and so we load the bitmap that way. So I think that's it. That's all I did. There was some other minor defects, but ABI pointer was the big one, and a few error pointings. I also had one error in this file, and what I'm taking the approach now is anytime I get an error, a compile time error, and I don't like the error output, I pause and I go and fix all the error output, and I had to go really deep into one bit because it wasn't deep in one of the codes, and it couldn't report the proper error, so I went quite deeply there. I don't remember what error it was, though. But that covers it, and so what I'm going to do next is I'm going to start wrapping some of this and start doing high-level things. I'm going to look at the SDL framework, how we actually draw a rectangle or something. The first bit is to actually create a rectangle and show it and put the bitmap in multiple places. And I think that'll be the next step, because we can actually deal with the rectangle, and I'm anticipating a few issues. Because of that thing, I have to be able to pass null or not null, and that'll mean converting to ABI pointers back and forth. But I think it'll work, probably one more conversion function. And that's all I wanted to do for today's update. I'll write a short write-up with that and post this. And again, if you want to join me tonight, we'll be doing the botters, Rust botters. It'll be a bit later in the evening. We're made it up to gold, and we're hoping to make it to legendary yet. Legendary doesn't exist, so we can't get there yet. We snuck up over to rank 56 overnight, so we're in a good stable bot. And we'll keep doing that and over the weekend. And then next Friday I'll come back with a Leaf update and see where we are. And hopefully within the month we can start doing actual graphics for the algorithms. That might be a bit more hopeful. I should actually rephrase that. We can do any sort of graphics actually loading things. Alright, thank you for watching.